So light by definition is supposedly something that does not have any mass. And this actually kind of threw me off for a little bit, and I was reading about it a little bit, and I think I might be able to explain why this is for people that might be confused on it, because it kind of sounds like it contradicts a couple things, depending on how you want to look at it. So how does this really work, though? So before we get into this video, we have to really think about what is mass by definition. It's usually, by definition, it could be an unreasonable size, whether it's big or small, and it forms a form of energy. So to say that, see, this is what really threw me off, was that to say that mass it can actually exist or not exist or even not exist at all, there's still got to be something there, whether it's negative or positive, but there's always more to what we know. So really, here's the argument we're going to be making. Perhaps, even though we don't know everything, it's going to be two things. Either one, maybe there is such thing as negative mass. How would that realistically work? And the fact that everything is still made of energy, regardless, if you want to argue that even light isn't. Some people might argue light isn't like the same kind of energy we see. Like, it's kind of like making the argument, what's the difference between matter and energy? There's some people believe there's subgroups differences, but really in the end, over time, it really is the same thing. Matter and radiation, for example, they're still forms of energy. They're just done a little bit differently, parts of different cycles. So in quantum physics, you have to study energy for what it is, especially acceleration. How is it that, and this is like kind of one argument you can use to disprove like the first law of thermodynamics in the state where it says that, energy cannot be created, but it's true though. Everything's made of energy, and everything uses energy to create more energy. You want a good example? Look at a supernova. When a star blows up, all that material goes back into the universe, but you have more mass there. Because as we've seen, galaxies have been known to increase in size. Planets, Venus is another good example. With its compressed atmosphere and all that, it's slowly expanding and getting even bigger. Planets do the same thing when they hurl through space. They generally grab more mass. Same thing with ions and subatomic particles as they're, like nuclear fusions and fissions. They're burning stuff, creating different elements, and then it's just sending it, it's on its way. Everything, basically, the argument starts out like this. Everything that moves in space is using energy. The energy itself is then converted into something else, but at the same time, though, it's changing it into something else. Chemical and physical change is a really good example. You can change the properties of something without actually changing it, but then that's what a physical change would be. But then you have like a chemical change where you're changing the base properties of something, but it's still the same, but it's becoming something different and becoming much more. Like, I'll give you another example. How is it that we could take like a bunch of elements and turn them into a bunch of subatomic formulas? Or if you want another good example, like say somebody was able to create their own water supply using just H2O. I mean, if nature can do it, obviously it's got to work somehow. So, to say that, like, same thing with light photons. If they weren't able to be, if they weren't like some form of energy, and if they didn't have like some kind of abundance of mass, how is it able to become energy? You know what I mean? Like, if it's not energy, it's got to be a different kind of energy, before it becomes its full use. It's like antimatter and dark matter, or antimatter and normal matter. There's an infinite number of possibilities they could be, and there's different types of dark matter and dark energy and dark flow, if that exists. Wouldn't be surprised, but we're just throwing it out there hypothetically. It's possible, with all the different types of energy we don't know about, how that identifies as energy. Why does it construct as energy? Why is everything made of energy? I always thought energy and everything it's just the building blocks of life, kind of like they say with cells, for example. Everything's made up of something else, and it's just the basic properties of how things function. I mean, same thing with light. Light is basically plasma and stardust. So if that's a form of energy, over time it's got to be something. So it's just moving differently and it's constructing itself differently, but it's still got to weigh something. It might just be, sure, you could say it's just a different type of, you know, I mean, if to say that light particles don't necessarily make sense, that'd be like saying like a star doesn't have its own mass at some point. Like, how does that make sense? You got a big ball of gas that's made of plasma and light particles, and that's practically the only source of light we know of in the universe is stars. How to say that like a photon cell or something does not have like some kind of energy? Maybe, I mean, if it's less than zero, that's understandable. You could make the argument that there is no such thing as negative mass, but up until what point though, where it's less than zero, or like what it is by definition of a mass? Because here's the way I look at it. If our universe is made up of a particular matter, then it's got to be what the definition of there's no such thing as negative matter, because it would have to be all positive matter. Now, there's more than one way this could happen. Just like the opposite, there could be a universe that's parallel where it's nothing but antimatter, negative mass, and that's just it. It's, it has to work in a certain way. So I wouldn't say photons don't have like, they can't have like some kind of a mass itself, or it's not some form of energy. It's just a positive kind of matter. It have to be some. So you have an infinite number of possibilities is basically the argument I'm getting at. Either that or it's finite. But I would actually argue it's easier to explain something that's infinite than it would be to explain something that's finite. Because the problem with something being finite is that at some point you're going to have to say that what was the very first thing that happened and how did that go from nothing to something. But in the world of quantum physics, nothing is still something. So if you have like this endless loop that everything just keeps expanding and then there's something previously before it, then it really does seem as contradicting as it does, that really there really is no beginning or no end, especially with energy being its own immortal state. You can destroy something and it's still there, but in a different form. Maybe you don't see it, but it's there though, just a little bit different. The fact that everything moves in space is another good example. It uses energy to accelerate. And, you don't want a good example, look at inhabitants of planets like us, humans, and other species that we know about. Their genetic coding, their physical appearance, their genetics, their energy. Stars are another good example. Heat source, plasma. To say that they don't have like some kind of a mass is like saying that, energy doesn't use mass, but it just doesn't work that way. So really, I think it's something that we still have to figure out. But, as far as photon using mass goes, I'd actually argue it does, because you'd have to be able to explain how something even qualifies as energy and it's able to exist as energy without using energy. The only thing I could think of is it's converting its energy. It's not using energy, but it's efficiently restoring it somehow. The fact that I'll give you another example. Here's something complex to think about. When you think it starts off simple. Here's the paradox. It's momentum at its finest. When something travels faster, it uses more energy. The universe is a good example of this. A perfect example of this, because we know for a fact that light is not the fastest thing in existence anymore. We have proven that, like with black holes' gravity, light can't escape from it. So what does that mean? So if that means that black holes work the way we think they do, where acceleration can just pull something in there and then it goes flying in some other dimension, wherever that is, however that works, that's another argument. But what it has proven is that it proves that light can be beaten, and therefore it uses even more intensive energy, that something implodes on itself. So that energy goes somewhere else, because that energy can't be destroyed, but it can be transferred though. And that's probably what black holes do, and it creates new universes. Would explain how ours was created then if there was a Big Bang. It just came from another dimension. Makes sense. But at the same time though, but here's where it gets confusing though. Okay. How does that prove that energy has mass? So, again, we have to think mass by definition is basically an abundance of something. It's still something. Even nothing is still something in the laws of quantum physics in an infinite universe, in an infinite number of universes. So it's like infinity to the infinite power, basically, and beyond that, if you want to argue that. But that's the thing about overthinking things. It might seem like a contradiction, but then again, it's like, how do you explain a lot of this other stuff too over time? So I do think that energy, light is still energy because it has to exist as a reasonable source of energy. It has to be a form of existence. It's something, but it's still something in the sense that it operates in some kind of a reasonable aspect. Because if it didn't exist the way it did, it would have unnatural law properties, but that's what makes me believe that there has to be some kind of advanced thinking behind it. For the example of a star to hold its mass for as long as it does, and things can rotate around it at a reasonable speed where it doesn't just get eventually incinerated by it or it explodes, and then all that energy eventually goes into something else, but it's still there nonetheless, creating an infinite cycle, and it's able to sustain life in an otherwise cold universe. Because if you don't know, again, the universe is mostly, you have subatomic particles and bacteria that can survive it, but it's mostly, like negative 500, almost 500, if not 548 degrees Fahrenheit, something like that. It's intense, but it depends on where you're at, but it's still nothing that we could ever survive. But there's bacteria that can, which leads me to believe that bacteria exists on every planet because of all the different possibilities that it can stick to any surface, it can fly through space, and then over time it eventually just lands on other planets because asteroids pick them up. They stick to that surface. They go from solar system to solar system. They end up on another planet, and it kind of explains why, our bodies, we have like more unknown bacteria than we can explain what we have, and so it makes me wonder, what else do we not know? How big the universe is, the progress behind it, and the evolution state behind it. Because everything's different one way or another, but it all operates somehow. And the way we see it is just proof of that. It proves that there's an infinite number of energy, and it also proves that, light and everything has to operate in its own infinite cycle. It can be destroyed. Photon eventually finds its way into some other ways, but it has to have a mass or some kind of mass, whether it's positive or negative, because it's still a form of energy. It exists. It's a physical object, whether it's radiation but again, it's still a form of energy, but done a little bit differently though. And there has to be some kind of force behind it, like just some kind of acceleration pattern or just some kind of physical property that gives it the ability to exist in the dimension that it does. And that's really the best way I can explain it, because, we exist in this reality. For example, another good example would be it's got to be something. It's got to have its own mass too, because it's giving off energy. The sun exists. It's able, heat is not something you can just go passing through and without being incinerated. Not as visible as the sun. If you were to go to the sun, you would die. You would die before you even touch the core. Again, the point I'm getting at is the photons that we see reasonably burning as high as they do and as hot as they do. A star is a physical object, so it has to exist somehow, right? So if it wasn't something, it would be nothing, and it would just be it wouldn't be as transmissive as a ghost, but it would be but it's still there. It's a gas. It's a giant ball of gas, plasma. So its capability, it can burn you because that's what it does. So it produces heat from a distance. The closer you get to it, obviously, the hotter it is, but the sun moves. Photons move. So it has to, and the sun weighs something. It's got its own, it's what is known as a solar mass, for example. So, obviously, there's a bunch of photons. It's not just a single particle. That's basically the argument. But yes, stars can have a mass, and so can photons. It's just reasonably, I think we just underestimate like weight and classification, because again, there's always a study somewhere somebody can pull up and they can research it a lot and see what they come up with. So this is just a little explanation, though, just how we really see this. Not just my opinion, but why I see some people say, like, how can a negative mass exist? Well, they're not referring to weight necessarily. They just start referring to like the kind of classifications that they might not really realize they're talking about, that would otherwise tell the difference between what, like, for example, the matter that we see versus antimatter. But yeah, matter, as far as the photons that we see in our universe, they have to have a reasonable mass. I mean, even if we don't know what that mass is, it's got to be something that just makes sense in our galaxy. It's got to be, maybe it's a positive. I do think so. But, even if you were to look this up on the internet, they would say it's 0 or, but it's probably debatable. Like, we just don't know everything, is basically what I want to clarify. And I was kind of confused until I had to make this video to kind of like really explain it to myself and explain it to a lot of other people, that what we don't see is not always what justifies something. Something that's invisible to our eyes doesn't necessarily mean it's got a negative mass. It could have a positive mass because it exists in our universe somehow. And it just makes sense to say that. So if you want to talk about visibility versus invisibility, but that's, I don't know, it's debatable. But anyways, again, if you enjoyed this video, please subscribe. I'll be making more if I find something that's very interesting. But yeah, if you have any questions, let me know. If you want to point something out to me, there's always the comment section. I read my comments, so I always like to hear what other people have to say.